This video is going to show you how to complete calculations given a balanced equation. Before we can begin looking at this, we have to consider our triangles that we've seen before. So there are two that were introduced at National 5, our mass triangle and our concentration triangle. We also have a third one at higher chemistry only, which is your molar volume triangle. What you'll notice is that they all have one thing in common, being number of moles, so N appears in all three triangles. This is important to allow us to work between the triangles. So if you have N for one, say in the mass triangle, you have N in another, so you can intertwine your answers there. So then we take our balanced equation calculations. So the method we follow is a three-step method. Every time you see a balanced equation, most of the time it's going to be this format, where first of all you calculate your number of moles for any given substance. Step 2 is apply the mole ratio, and step 3 is your final calculation, whatever that might be. So we'll take one at a time and you will see the three different triangles crop up at different points. So first thing I do is see what numbers and information I have in the question. So you'll see question 1 is asking you to calculate the mass of water. So find water in your equation, which is here. Based on your triangles, mass is an A or an M, whatever one you're used to. So A, and I'll write question mark, so I know that's what I'm aiming for. I also have a value for methane. So it says 48 grams of methane. Now find methane in your equation. Based on what you know about chemistry, you should know this is methane. 48 grams is a mass, so you do need to be aware of your units and what they refer to in the triangle. Now that's all the information this question gives us so far. What you need to calculate and what values you have. Then you can go on to step 1, so calculate number of moles. You see at this point, I know nothing about oxygen and carbon dioxide and I don't want to know anything about them, so I can just ignore those two. These are the two things I'm interested in, so that's what you should calculate the number of moles for. I only have one value, so I can only calculate the number of moles of methane. So I'll write N, I'll just write methane's formula to keep me right, equals mass, so A or M, over gram formula mass. The mass is given in the question is 48. The gram formula mass you would have to calculate separately, as you should already be aware how to do using your data book. It works out to be 16. In your calculator, that gives you 3 moles. Step 2 is the mole ratio. Now, reason we do this, I have the number of moles of CH4 now being 3, but I want to know how many moles of water I would have from that. So for mole ratio, you take the two things that you're interested in from the equation. So CH4, because I highlighted it, and water, H2O. So you're just rewriting the equation, essentially ignoring everything else. There's 2 steps to the ratio, so the first part would be from the equation. So CH4, there's no number in front of CH4 in the equation, meaning there is 1 mole of CH4. Whereas water, it says 2 H2O, so in the equation there's 2 moles of water. Now that would be a perfect scenario where if you had 1 mole of CH4, you would make 2 moles of water. However, you'll see from step 1, we have 3 moles of CH4. So really what I then do is take that 3 moles of CH4 and rewrite it underneath. Now if we compare this in the mole ratio, 1 to 2 would then be 3 to 6. So if 1 mole gives you 2 moles, 3 moles it gives you 6 moles. There's other ways you could consider that. Some people prefer to look at it in terms of a wee calculation there. So you could say, well, 1 times what gives me 2? Well, 1 times 2 gives me 2. So 3 times 2 gives me 6. Just depends how confident you are with ratios. Step 3 is our final calculation. So in this one we wanted the mass of water. So A of H2O equals N times GFM. N I've already worked out from step 2. I have 6 moles. GFM, if you do your normal calculation, is 18. Be careful. What some people might do is put that number as 32 because they've did 2 H2O. GFM is for 1 mole, so you just ignore the number in front at that stage. That number in front only matters in the middle section. So 6 times 18 is 108 grams. So just to finalise where that number came from. So highlighters can help you arrange your information but also follow numbers throughout. Final answer, make sure there's units and you double underline it. So I'll go a little bit faster through example 2 then. So same thing, you want to pull information from the question. Calculate the mass of magnesium. That means we're aiming for what A equals. And we have more than one number this time. So we have 50 cubic centimetres of a 2 mole per litre solution of hydrochloric acid. Now there's hydrochloric acid there, HCl. 50 cubic centimetres is a volume. Our volume triangle always uses litres instead of cubic centimetres. So I would just convert that just now by dividing by 1,000. So that would give you your 0.05 litres. So now I've pulled all my information. I want to make a start. So step 1, number of moles. I only have values for HCl. So I'm doing HCl. This time I have a volume. Also forgot to put in there, I have a concentration from the question. So I'm not using the mass triangle this time, I'm using the concentration triangle. So C was 2, V was 0.05, which gives you 0.1 mole. So it's not always the mass triangle. Step 2 is your ratio, so take what you are interested in, ignoring the rest from the equation. So mg, there's no number in front, so you take it to be 1. 2 HCl, you take it to be 2. From the information we've worked out though, we have 0.1 moles of HCl. So find HCl in the mole ratio, which is on the right hand side, and write your number down. So now we need to figure out the missing number. So 1 times something gives you 2, 1 times 2 gives you 2. So our missing value here is 0.05 mole. Step 3 is final calculation. So I want the mass of magnesium. So A of Mg equals N times GFM. N we've worked out to be 0.05. GFM in the higher data book is 24.3. It is different in the National 5 data book. So just take care there, use the number that's in your data book. So my final answer, using that GFM, rounds to 1.215 grams. Just note, if you compare the highlighting in the two, the mole ratio section is the opposite way around because you follow where your number's going. So just make sure you understand where that's came from. So final section, this only applies to higher, so National 5 does not need to consider this at all. So calculate the volume of carbon dioxide release. So carbon dioxide is there. 0.5 grams of calcium carbonate reacts with excess hydrochloric acid. So 0.5 of the calcium carbonate. So I want the volume of CO2. I have a mass of calcium carbonate, and it also mentions here the molar volume is to be taken as 22.4. Now molar volume applies to gases, so from the two values, two formula we want to know about, we have one gas. So the molar volume is to be taken as 22.4. So we'll just match that up there. So step 1, number of moles. Now you could do it for either, arguably, because you have values, but you don't have enough information to use the molar volume triangle yet. So we can only use the mass triangle and do CaCO3. So we're doing our mass over gram formula mass, which will give you 0.5 divided by 100.1, which rounds to 0.004995. Don't round too much just now, because if you rounded that to 0.005, it is going to drastically change your final answer. So just keep the number in your calculator. Step 2, compare the two things you're interested in. So if we take the CaCO3 to the CO2, they're both 1 mole because there's no number in front. And taking the value from the previous section, we have 0.004995 of your calcium carbonate. And then you have the same again, because it's 1 to 1, so same value. And final step then, we are taking that value and doing our final calculation. So our final calculation should be the volume of CO2. From your triangles, that is N times MV, which would be 0.004995 times 22.4. Just running out of space there. So if we take where that came from, it's from that section. 22.4 is from up here. So my final answer is 0.112, and that's litres. Just be careful, your L for litres doesn't look like a 1. There. So there's my final answer. So these tend to be worth 3 marks, a mark for each section. Please take care with GFM, because that tends to be where people lose marks. Always double check it in your data book, and also make sure you are confident in how to work out that ratio. It is just taking a wee bit of time to practice it.